start out by asking, and just raise your hand. Has anyone ever felt an earthquake? Really?
Yeah.
What did it feel like?
It would do take a heart.
Did anything fall? No.
In second grade, we were just cleaning up the room and then it starts moving around in the classroom. Oh, yeah.
You never had an earthquake in school?
Every time there's an earthquake, I go in my dad's room and go under the,
Not even this
go
year.
under the blanket. And then I check my dad because I'm scared.
It's better to go underneath the bed.
Yeah, that's better because
Then the bed will protect you. Here's another question. We'll get to all these later. But here's another question. Does anybody know what causes an earthquake? What? That's right. The earth
no,
moves.
it's hot air and cold air.
No.
Oh, so that was bad.
It's the earth moving. The earth moves on what we call a fault. You ever heard of a fault? Hayward Fault. Hayward Fault is where Mr. Carter lives.
I want to go there.
You were pretty close to me.
What?
It's a place that's it's a very weak place in the Earth's crust, and the Earth can move along that fault. And when it moves, every now and then, not often, but every now and then, it makes the ground shake. And that's when you feel an earthquake.
Have you ever been in a?
You know what to do? If you're in the classroom, do you know what to do if there's an earthquake? Come on.
Go under a table and put your hands over your neck.
And one other thing. Actually, it's better not to, if you're under the table, you don't have to cover your neck. The best thing to do when you're under the table is hold on to the table. You know why?
So it doesn't move.
That's right, because it might vibrate and move away from you, and if that happens, then you won't be protected anymore. So if you're over here and there's no table over you, you should cover your head. But if you're under the table, hold on to the leg. And then if it moves, you can move with it, right? So let me back up just a little bit. I am a geologist. What did I study? Rocks, yes. Even before that, I studied science. Who likes science? You all do. Oh, good. You have to like science if you want to be a geologist. You have to like science. And it also helps if you like math. You like math?
Not really.
Science and math are very important in geology. And the more math and science you can learn, and the more you listen to Mr. Carter when he talks about science and math, the better off you'll be. Even if you're not going to go into geology. You want to try any of this. Like for instance, when I started out, I thought I wanted to be a chemist. I wanted to do chemistry. I wanted to pour chemicals from one test tube into another and see what happened. And I wanted to do experiments with chemistry. And I started out doing it. But you know, I didn't like it so much. It was kind of boring. I could do it, but I didn't like it. Then, this happens in college sometimes, you take a class that you didn't think you were going to take. So I thought I'd try geology. I took a geology class. Guess where I went? Outside. Not in a laboratory inside the class. I was outside. And I went outside, and I took a rock hammer.
A rock hammer?
Yeah, just like this.
You're gonna smash your head. It looks like it's gonna.
Just like this.
Oh.
And I broke a rock, and I looked inside and found out what was inside the rock. Sometimes it's very interesting what you find inside a rock. It looks very different than what you see when you're walking along on the street. You see a rock. It's not as interesting. It's kind of weathered, we call it. And when you break it open, it's a nice, fresh piece of rock, and you can see exactly what the rock is. Because that's one of the most important things you have to do in geology, is identify what kind of rock you're looking at. Who knows what kind of rocks there are? I notice up there you have, the sun is lava. Well, lava is a type of volcanic rock, right? If it erupts out of a volcano, that's called an igneous rock. There's three types of rocks. Igneous.
Mineral?
There's minerals in the rock, yes. That's how we identify the rocks, by what kind of minerals they have. There's an igneous rock, there's a sedimentary rock, which is lava rock. And the sedimentary rocks are kind of interesting because they form in creeks and lakes. When sediment, like if you threw a handful of dirt into a lake, what would it do? Settle slowly down and sit on the bottom of the lake. Well, after millions of years, that would become a sedimentary rock.
Millions?
It might take millions, yeah. Yeah.
Kind of like a century.
Yeah, exactly. So, the other thing I like about geology is, what do you do when you put these on? You go hiking, right?
Yeah, my
I
dad
did a lot of hiking. And when you go hiking, you stay in good shape, you get outside, you're out with the birds and the bees and the rocks and the trees. But I've had these boots, as you can see, I've had these boots a long time. But that's what I like about geology. I'm outside, not locked up in a lab, and it's good to be outside. Very healthy for you. So,
and get the
I've been a geologist, like I said, for 35 years, and I'm retired. I still do a little work, not much, just a little bit here and there. Where I work is all over California, sometimes outside of California, but mostly in California, all the way from the north, up by Oregon, down to the south, by Mexico. And when I first started out, my first job in geology was to make a geologic map. So you know what a road map is, right? You take a road map, and then you walk along, and every time you see a rock, you put a little mark on the map. And then, like if it's granite, you might put a red spot on the map. And everywhere you see granite, you put little red spots. And pretty soon you know where all the granite is. Then you go over and you see some lava rock. Some igneous rock that came out of a volcano. You might use a different color for that, blue maybe. And every place you see a lava rock, you put a blue dot. And pretty soon, you cover the whole map and you know where all the rocks are. Then the second thing you have to do is look for the faults. Because the faults move the rocks around. Like I was saying, along the Hayward Fault, when the Hayward Fault moves, it moves the rock. And so, a lot of times you might think, gee, there should be some more granite here, but it's gone. Where did it go? Well, maybe this fault, like the Hayward Fault, took it maybe 100 miles away. It can happen. It takes millions of years, but it can happen. So that was kind of my first job. After that, I kind of migrated into hazards, things that can hurt people, things that are dangerous, like earthquakes, of course, and landslides. Have you ever seen a landslide?
No.
You know what do you think it might be?
When you slide them, like a U.
You think it's on a hill?
Yeah.
And then what happens?
I think I know. You run down.
It rains, and the soil on the hill, when it rains real hard, it comes right down. And if there's a house down at the bottom of the hill, that's not good, right? So it's good to know where the landslides are so you can stay away from them. So you don't build a house back down at the bottom of the hill. You build it over here where there's no landslides. Here you don't build. Unfortunately, over the years, we don't always stick to that rule. And we built in places we shouldn't have built houses. And it just happens. It's all over California. It's all over the world. But at least knowing where the hazards are is a good thing to know. And that's kind of what I've been doing for the last about 20 years. Landslides, mudslides, areas that might flood. You know how when it rains a lot and the river rises and it goes over the banks and it floods, how far might the water go? That's one of the things I was pretty good at guessing. How big a flood we might have.
Like all the way to the end, I think. The top of the land.
Yeah, I've seen some very, very big floods in my time. And sometimes you wouldn't believe how much water there is.